So average rate of change given a function y equals f of x. So given the functions, any random function, y equals f of x, average rate of change is delta y divided by delta x. By the way, what's delta? The change in y divided by the change in x, which is f of b, take away f of a, all over b minus a. So AKA, if you see that formula, what's a fancy word we used back in Algebra 1? Slope. Slope, okay? So average rate of change is just simply a slope. And let me just kind of sketch out something here for us. Okay, so we have A, we have B. Let's make a dot for, let's draw a line. There you go. So this is f of A somewhere up here. F of A is just simply what? The y value at A, right? Here's f of B. Okay. So it's saying the slope is the average rate of change. But no, in Algebra 1 and Algebra 2, we didn't really use this word. If you have a line going through 2 points, this line is actually called a secant line. Okay, so a secant line is a line that runs through 2 points. So the average rate of change is the slope of a secant line. Because later, a tangent line, from what you guys remember, what's a tangent line?
It's where it's a line that only touches one point on a graph.
Right, right. Later, in a little bit, very soon, bottom of the page, we are going to define the tangent line, which is not 2 points. It's just what? 1 point. Okay. So find the average rate of change of the function f of x equals square root of 4x plus 1 on the interval. Part A, on the interval from 0 to 2. So, how many points is that? 2. A is 0. So let's find f of A. How do you find f of A? Plug 0 in for f of x. So it's going to be 4 times 0 plus 1, which will give us what? 1? What's your b value? 2, because it's from 0 to 2, so that's your b value. So f of 2, plug it in. 4 times 2 plus 1, which will give us what? 3. Perfect. So based on your slope formula, what are we going to do? 3, rate of change. 3 minus what? 1 divided by 2 minus 0, which is 1. So it is saying the average rate of change for that curve from the location of 0 to 2 has an average rate of change of what? 1. Do you think it's going to be the same from 10 to 12, which is part B? No. Okay, let's figure it out. A would be what now? 10. So we don't have a calculator, so we'll just keep our exact value. 10 times 4 is 40. 40 plus 1 is 41. It's not a very nice number, so keep it. Is that okay? And then B, whoa, B would be 12. Did it come out to be a nice number for B? Okay. So f of 12 is going to be 48 plus 1, 49, so 7, okay? So based on our formula, It's 7, take away square root of 41 all over 12, take away 10. On the numerator, not much we can do, so we'll leave it as exact. On the bottom is over 2. Someone, just if you have a calculator right near you, can you punch it in just to get an approximation? Just so we can talk about the two different average rate of change. 0.298. Okay. So here we go. On this curve, from 0 all the way to 2 has an average rate of change of 1, which is an average slope of 1. From 10 all the way to 12, it has an average slope of 0.29, about a third. Would that be okay to kind of state? Why are they different? I thought slopes are supposed to be the same.
Because it's not like linear line.
Yeah, it's not a linear graph. So when it's not a linear graph, would you agree that the rise of a run, the rate is different at each location? Which one's more steep? Which one's steeper? A, right? Because that's a rise of 1 and run of 1. Over here, it's about a third. So what's happening is like every step you take, one step you take up, you have 3 horizontal steps to go over. So it's not as steep as the first one. So the further out, looks like the further out you go is less steep, right? Okay. So now what happens when you have tangent to a curve at point P? So tangent is when only one point is given. Only one point. One point is known or given. Okay. So how do you find the slope if there's only one point? Don't you need 2 points of the slope? Okay. So I'm going to spell out everything verbally first, and then we'll practice it. First, we will start with what we know how to calculate, which is finding the average rate of change, which is the slope of a secant line. That means how many points will you need? 2, okay? But you were given 1. So we will start by finding the average rate of change of a secant line through the point P. And point P is the given point from your question. Okay, so point P is the given point. And a point nearby. Let's call it X. Okay. So you are given 1 point. But obviously that's not okay to find the slope. So we are going to pick somewhere nearby, to the left or right. We're going to call it X. Number 2, we will find the limit of the slope of the secant line as X approaches. What is X, by the way? Yeah, point nearby. Point nearby. Okay, as X approaches point P. What's P again? Given. Okay, given. I'm going to hold it right there before I go. Can you guys see what we're about to do? You're given a point P, but you don't have 2 points to find the slope. So we're going to randomly pick a point nearby. Obviously, the closer to P, the more accurate your line will be. So in math, that's how we manipulate it. We pick a point nearby as the limit, okay? So as the limit approaches your P. So whatever x you pick, we want this x to be very, very close to what? To P, okay? We defined the slope of the curve at point P to be this number. Let's call it L. Okay. Whatever the answer is, we call it L. So L is the slope of the tangent line at point P. Okay. And again, I want to kind of talk more about it. So do we want the point nearby to be so far from P or very, very close? Close. Very, very close. So that's what it says here as x. This x nearby point approaches P in essence. So if P is -5, we want this x to be either a -5.1 or a -4.9. We want it super close. Now in mathematics, when we draw things out, we can't really draw it as well as if we would use decimals, right? So technically, I can use, in decimals, I can use as close as I can write the zeros. So the difference between a tangent line requires how many points? 1. When we touch your curve at 1 point. A secant line requires 2 points. Should we keep on going or should we stop? The more we do here, the less you have. Keep going. Okay, let's go. All right, so let's practice on example 2. Is that difficult? Yes. Okay. Well, concept. It's because it's so new. Okay. It gets harder. Okay. Here we go. Example 2. For y equals x squared minus 4x at given point x equals to 1, find the slope of the curve. And B, write an equation of the tangent. In your book, when it says write an equation of a tangent, it's the same thing as writing an equation of a tangent line. Okay? So, how many, I'm sorry, yep.
Sorry.
No, go for it.
For point x, you say nearby. You mean nearby on the line of the function.
On the curve, on the curve of the function. Okay. Yep. So I can have a cubic, a quartic, a quadratic, whatever, as long as it's nearby on the curve. We'll definitely practice more. So, okay. So here we go. Here's a curve. This is a parabola. Would you guys agree? Okay. You are given how many locations of x? 1 is looking for the slope. So is this a secant line or is it going to be a tangent line? Tangent, because it's only touching this curve at exactly 1 location, which is x equals to 1. So first, we want to do x is 1, so let's find f of 1. We're going to plug in 1, so 1 squared minus 4 times 1, which is -3. So would you agree your point x is 1, y is -3? I'm going to hold it right there before I go by. Yes, no, maybe? Okay. So would you agree the definition said pick a point nearby? Let's call it x. But technically, do I have to use a variable x? No. So point nearby. Your current location is 1. Now hold it right there. Would you guys agree with that comment? Your current location is 1. I want a point nearby. That means it can be on the left or on the right, it doesn't really matter. I'm going to write 1 plus h. Hold on tight. Don't stress. Okay. 1 plus h. Okay. Now I'm going to write this. What do you think h is if I write 1 plus h? Yeah, couldn't h be that small value? 0.0001, or if I wanted to, the other side, negative something. Okay, so that's what h is. H is the gap, right, of the actual point and somewhere to the right or the left. It doesn't really matter. H right now is, we don't know. We want to be super close to 1 though, so that means this h value should be getting closer and closer to what? 0. I want my gap, right, this h, which is the gap, to be very, very small. So the smaller it gets, the closer I will be to the x equals to 1. Okay, so my nearby point is 1 plus h. So let's find f of 1 plus h, because wouldn't that give me the second point? Would that give me the second point? Yeah, let's plug it in. So this is going to be quantity of 1 plus h squared minus 4 times 1 plus h. Distribute that out. It's going to be 1 plus, in the middle, 2 h's, plus h squared minus 4h. Check my basic math. So far, so good? So I would have 1h squared. True or false? And then, how many h's? Negative 2 h's. And then the constant would be minus 3. I'm going to hold it right there before I go any further. So would you agree? Now, nearby point has an x and a y coordinate. Nearby point. What is the x coordinate? 1 plus h. What's your y coordinate? H squared minus 2h minus 3. I'm going to hold it right there before I go further. Would you agree with that statement right now? So, and then it's the instruction said, okay, now we are going to use limit. Okay. Limit h approaches. What is h? The gap, right? The gap between, remember, the nearby point, I'm not picking 2. I'm not picking 1.1. It's just whatever it is. So what do you think h needs to approach? 0. My gap needs to be approaching 0. Right? Over. Now we're going to write the normal slope, which is f of 1 plus h, which is your f of b, isn't it? Minus f of a. F of a happened to be 1. True or false? All over your x, your b minus a. Well, b is really 1 plus h. True or false? And what was a? Minus 1. I'm going to hold it right there. It's so important that we understand this right here, this process. Okay, remember, isn't this right here my slope formula? F of b minus f of a divided by b minus a. But remember, we pick a nearby point of 1 plus h. H is the gap, right? So we want that gap to be very, very small, pretty much nothing. So now, do I know this component? What's that component? This right here is y. What's this value? Right, we found it. So we just have to plug it in. So limit as h approaches 0, f of 1 plus h, that's the y value. Okay, minus, what was the y value when x was 1? Negative 3, all over. Would you agree that these two ones would cancel each other out in the denominator? So we only have h left. Are the 3's canceling each other out as well on the numerator? Because the 2 negatives would make it a positive. So what can we do next? Factor out the h. You have h minus what left? 2 all over h. Can I cancel that h? Yes. So now can I substitute in my 0? Correct. So what is the slope? -2 is the number L, right? -2 is that number. We call it L. So this is the slope of that curve at what location?
0.
Yes, at x equals to 1. Yeah.
Oh, sorry, I just didn't know that.
Yes, yes. X equals to 1. Remember, h is not the x value. H is the gap between your nearby point and the location of x. So we have the slope. I'm sorry, yep, you have your hands up? Is that?
Yes, I just want to ask.
Yeah.
So if x equals 1, then would it be the L over x? Or is that already the slope?
That's the slope of at that point.
Okay.
Yeah. So if I were to verbally say it, the slope when x is -1 of the curve x squared minus 4x is -2. Okay. Remember, tangent can only touch it at one point, so you can only touch it at that x equals to 1. So now how do we find this tangent line? Y was mx plus b. Right? Or I have a slope, which is what? I have a point, by the way, with my point. 1, -3. What other formula can I use? Point slope. You're right. Let's do point slope because in calculus I don't have to simplify. So point slope is y minus y1 equals to slope times x minus x1. Your point was what? 1 comma -3. Your slope was found using calculus of what? -2. Let's plug it in. Y minus -3 is really plus 3 equals, the slope is -2 times x minus 1. Box that up. In your book, it may have a y equals mx plus b form. It doesn't really matter, okay? Now, let's sketch it out to see if it kind of fits, okay? Okay, first let's sketch out your x squared minus 4x. So your equation originally is x squared minus 4x. Anybody know the vertex straight away? So the vertex is -b divided by what? 2a. b is -4, so a negative of a -4 is now 4 divided by 2 times 1. So that's going to be an x coordinate of 2. Let's plug it in. F of 2 is going to be 2 squared minus 4 times 2. So the y coordinate of your vertex is -4. Okay, so 2, -4, 2, -4. Then all I have to do is pick one more point and then reflect it. Would you guys agree? Let's pick 0. When x is 0, what's your y? 0. And then can I just go to the right side of my vertex and mirror image that? All right. Now this secant line, it's supposed to be, I'm going to graph that line. You have a point, let me get another color, of 1 comma 3. I'm sorry, 1 comma -3. So 1 comma -3. Is that the point? And then the slope was -2 over 1. So you can go down 2, right 1, or left up 2 and left 1. Doesn't really matter. Do you think it should only intersect it at one location? Yes. If somehow, obviously graphing by hand is never as nice as if I were to have Desmos, but you kind of see where it's intersecting, right? Okay. All right, that's an egg roll for today. I'm holding your homework quiz for tomorrow. Obviously, you guys get out 34 and you don't have 10 minutes. First thing tomorrow is your homework quiz. You're right. You're right. But anytime, obviously, if I give you 2 points right away, you can just use full score and find the slope. But the tangent is only 1 score, so that's really the issue.
It